Thank you for coming back today at our channel, The Physics Mindset. Now, there is something I want to tell you today. We are still in transmission lines. Have you ever wondered, have you ever stood somewhere, wherever you are, in whichever country you are, stood somewhere down the high voltage transmission lines, the lines which pass through which pass on the transmission tower? Okay, you stood down and you heard a strange sound, a hissing, something buzzing, a hissing sound. Sometimes it even glows. Something strange under the high voltage transmission lines. Some hissing, some sound which is so strange. Normally during rainy season, when rain is going to, or wet seasons, okay? These sounds from these cables, from these wires, it is not a transformer. You can feel that sound, that hissing sound, that buzzing sound, as if they are birds, but there is no bird around. Something passing through the wire. If you have ever experienced that sound, it is not a transformer sounding or buzzing or hissing. It is not a conductor vibrating. No. It is what we are going to study today, and it is going to be called an corona effect. It is something called corona effect happening in this high voltage transmission lines. What causes this? We're going to look at it in this video. So this video is good for students studying electrical engineering, electricians, electrical technicians, and engineers already in the field. We need to know this. Mainly, what is this sound in the high voltage transmission lines? What do we gain from this? What should we know about this, which is called the corona effect? Technically, we call it corona effect. What causes this? Corona effect occurs when the electric field around a high voltage conductor, when the electric field around a high voltage conductor, those are on the transmission lines. We are still talking about the transmission lines. Those conductors, when there is electric field, let me first tell you something about electric field. If you see electric field, like for example, if you see a magnetic field, magnet is like this: North Pole, South Pole. Now, there is what we call magnetic field. This is the magnet, and it has field. Fields are something surrounding it. Now, something surrounding it. These are fields. Okay? Now, something surrounding it. These are what we call the field. Now, if it comes in electric field, take your mind to be a cable. Electric field. When electricity is passing through this cable, these are electrons passing through this cable. The surrounding area is the field. Now, the effect of this electricity passing through the cable is the field we are talking about. That's why we call it electric field. And our topic here is going to concentrate on what this electrical line, the high voltage electrical lines, happen. What happens on it when it is carrying high voltage? That sound you hear when you are standing under these high voltage transmission lines, you'll hear those sounds. And what are these sounds? Its effect is called the corona effect. Don't mistake this with coronavirus. Okay? This is corona effect in electrical. The other coronavirus is in chemical. Okay? Chemistry. Now we're talking about electrical physics. Corona effect occurs when the electric field, this is our cable carrying electricity, Now, this surrounding area, when the electric field around a high voltage conductor. Now this is the conductor. Okay, a high voltage conductor. Let us say it is carrying 400 kilovolts. A high voltage conductor becomes strong when this electric field becomes strong. When a high voltage conductor is carrying high voltage. Now, when the electric fields becomes strong, the surrounding, when it becomes strong enough to ionize the surrounding air, ionizing meaning, this is the air particles surrounding in the space. They are air particles. Now, these air particles, which are unseen, you cannot see it, you cannot see them. Electric field, you cannot see them, but sometimes when they become very strong, you can see them. We said you can see them by seeing some glowing or some flash, which is more bluish, bluish or violent. These are now the surrounding area has air particles. Okay, these are the air particles. For example, we are having our high voltage transmission conductor. This is high voltage conductor, the one carrying electricity. The voltage is 400 kilovolts. This cable, it's surrounding the electric field surrounding this conductor. When it becomes strong, it ionizes the surrounding air. It will ionize the surrounding air. It will collide with the surrounding air. And once it collides with the surrounding air, what happens? There will be more charging particles in the air. And that is when you will see the corona effect in those transmission lines. Though that's why they put them at a high altitude, at heights, to avoid this corona effect to affect we, the human beings, or the surrounding things. Because when the high voltage, let me give you, I want you guys to understand well this corona effect when you are studying transmission lines. The definition. Corona effect, when the electric field it occurs when the electric field around a high voltage conductor becomes strong enough to ionize the surrounding air. This is the cable on the transmission. Okay, this is a rough estimate. Now, this is our cable. Let's say one of the three phases. Now, this is the one phase. Okay, phase 1. It is carrying a voltage of 400 volts. When current electrons are passing through this conductor of high voltage, this is the high voltage conductor or conductor, becomes more strong when when high voltage is passing. It creates some magnetism around this cable, around the field, electric field, around it. Now, when it is about like rainy season, when it is when rain is going to come, you will feel the wind is strong in the atmosphere, in the space. Now, this wind will be moving around this cable. Yet this cable is carrying a strong electric field. And this strong electric field, they may collide with the air particles, the air or the air molecules. Let us call them molecules. The air molecules, small. And when they collide together, air molecules and the electric field, these are the electric fields, okay? Electric field, when they collide together, they form something you can see, a bluish or fire. Some people called it fire, electric fire, sparking around the cable. For example, let me give you a moment. When the cable is carrying this, the electric field, a cable is carrying high voltage electrons. Electrons will penetrate from the cable, and when the electric field becomes very strong, it will act with the air molecules. And once they act with the air molecules, something will happen, a glowing. This is why we see some glowing, which is like bluish. Have you ever seen electricity? Electricity is something you can't see, but the moment you see it, just know it is a corona effect. It is more of bluish or violent in color. That is corona effect has happened. It happens only when the electric fields, the strong electric fields, have ionized in the air with the air molecules. That is when you see this corona effect. That fire you see, that electricity you see, and it comes with a sound, that sound, that hissing sound, that buzzing sound. And you see a bluish electricity, or violent in color. That is what we call corona effect. It means this high voltage has created a strong electric field around a high voltage conductor. Becomes and this electric field, once it becomes very strong, it ionizes the surrounding air. Once it ionizes the surrounding air, it will make that the collision between air and this strong electric field, they make corona effect. And that's why you will see that bluish color of electricity, or that violent color with a sound, a hissing sound. Okay, sometimes with the high voltage transmission lines, you'll hear, when you stand down these transmission lines, you'll hear this hissing sound. But this is not a transformer, and the cable is not shaking, that it is vibrating. It is meaning there is some high electric field ionizing with air, and that sound, they are colliding. The electric fields is colliding with the air particles, air molecules, and this collision causes the corona effect. This corona effect, it brings, when the electric fields are very strong, it brings that bluish color. That bluish color, it means the electric fields are colliding with the air molecules, and their collision, they will cause sound, a hissing sound, small hissing sound you will feel. Take note and observe this sound. And once you observe very well, you may see that electricity, which is bluish, with that sound, and that is the corona effect. I never wanted to leave this behind in the transmission lines, because this thing happens only on high voltage transmission conductors. This topic is in the transmission lines, still in transmission, though we are about to leave them. But I didn't want to leave this back, so that you need to know, because this is a daily thing. You have ever experienced this? Technicians, students, even anyone, you have ever heard of electricity sounding on these transmission lines? These are the lines which are meaning. This is the pylon, okay? These are the lines. Live 1, live 2, these are three-phase, three-phase system, live 1, live 2, live 3. Now, if you are here, down here, on the road, This corona effect happens on these cables. On these cables. You know the hair between the spacing of this, that's why they space them with high space. One cable is the other side, another cable is the other side, another cable is this side. Because of the corona effect, the electric fields of one cable has high electric fields, which sometimes they make electromagnetism around the cable. And these high voltage, high electric fields, when they collide with air molecules, this effect bring that bluish color. And sometimes you see a glowing cable, a cable turning reddish. This cable, sometimes it can turn reddish in some parts, and this part in between the cable, the one cable which is transmitting high voltage, either 400, we said 400 volts. This part, either it is a fuse, it may turn reddish. Okay, that means high voltage is passing there. And this reddish part, if it finds this glowing, this corona effect, if it finds when the cable, you have not stripped well these cables. Now, technically, let me show you something which you don't need to miss. Okay, this corona effect, which causes that bluish color on the high voltage transmission cables, on the transmission lines or tower, when they find they are very strong, to see them, if you tie your junctions weakly, weak junctions can cause the corona effect. You can see it because if this is your cable, one cable is coming, another cable is coming this side, and you tighten them, you tight this one like this, okay? Now, and you leave a point of a cable. This corona effect, they like those sharp points, and that is where when current is passing, high voltage is passing, and it finds the ending, when the ending is sharp, the corona effect will come and pass, and that's when you'll see that bluish color, that violet color. It will come like this on the cable. The cable stops here with a sharp point, and corona effects, they like these sharp points. Whenever you see you do your termination, please, these sharp points, avoid them. The more this corona effect comes in, it will penetrate. Let's say if this cable, there is another, now this is electrical, this is, let's say you have done even solar system, another side. Now this electrical cable are near solar system. That's why it is not advisable to put your electrical cable and the solar system. Solar is using DC, the battery, and the electrical is using AC, alternative current. Solar is using a direct current. When you put them, this is a electrical, this is AC cable, then you put them in one conduit. It is not advisable. This is a DC. Now remember, electrical, it goes and comes, while DC, electric goes and comes, that is alternating. Now, while this is a direct current, it just go in one direction. Now AC will do some electromagnetism. This electromagnetism will penetrate in the cable of a DC, and your battery will be damaged, or your system, or your lights. You'll see all the time buying a DC light, solar bulbs. You don't know the effects just because you had put them in one conduit. One conduit. When you're wiring a house, you put a pipe work, then in that pipe work you put a DC cable and an AC cable, it is not good. Always separate the pipe work. Okay, then your system will be perfect. We shall come to that when we start the wiring part, the pipe works, and I show you how you do the pipe work when you're installing in the house. This corona effect will penetrate into another conductor and can cause things to fault. It can cause faults in some electrical things. That's why engineers came up and said to avoid this corona thing which jumps, this electricity which jumps when it finds a sharp thing, they decided to make these transmission lines, these lines to be very big. Now, to students, engineers and electricians, do you know why they use a very big diameter of these transmission lines? These transmission lines, one cable like this is a bit big in size. Why is it big? To avoid this effect of sharp end. And its end, one cable is like this, another one is like this. Now, one end is not sharp. If the cable, you cut it, it has a sharp point, it is not good in transmission. It is not good in transmission because of the corona effect. It needs to be with a very big diameter, cross section. Now, after getting this, when they are not sharp, the engineers, they twist this cable, one cable like this, the conductor, which it is three phase, 3 conductors. Now, one conductor, they get 3 of them. Try to see those cables. No, most of people, they use them for putting, if they find these cables, the cables they use, the conductors they use on transmission, some people they use them for hanging their clothes. Okay? Now, those wires which they use for hanging their clothes, the aluminum wires, the engineers get like 3 of them or 4. They twist them with a machine. The reason why they twist these cables with machine, to avoid corona effect. To avoid corona effect. And even their end is big. Is not small. Like our 1.5, 2.5 is not small. Their diameter is big. One cable has a diameter which is big. So that if the diameter, let us say this is the cable, the diameter I told you is the end point. This is the diameter. When it is big, corona effect will not jump. That bluish color you see at high voltage, it will not jump to go outside to ionize with the air molecules. It will end here in the cable. Now they get these 3 of them, they twist them, and it becomes one conductor, but with a very huge diameter, very big. They twist, they make one conductor. Try to check. You know, I told you to be practical. This channel is a practical, technical for students, technicians and engineers. Once you see a video, please try to take a look in your place, wherever you are. Go and observe what you have learned in the video, and so that you see whenever you go, you have done a practical thing and you will never forget it. Okay? Now, if you hear this sound on a high voltage, just know, this is corona effect happening. It happens when there is a strong electric field around a high voltage conductor. When this electric field becomes strong enough, it ionizes the surrounding air. And once it ionizes surrounding air, that electricity will start penetrating in this air because of the collision of the air is acting and the electric field is acting. In the interval of acting, you will see that bluish color on the cable. And once it finds a sharp point, corona effect, once it finds a sharp point, a corona effect will be high to penetrate, to pass. But once it finds an ending conductor, when the diameter is big enough, there will not be an effect. And this is the knowledge the engineers are using in transmission. The conductors which are transmitting high voltages, their ending is not sharp. They get 3 of them, they twist it to become one conductor, and its ending, it has very big diameter. Each has a very big diameter, and once they twist to make one conductor, it means it will look like this. Let me rub off this. It will look like this. Okay, this is one conductor. This is one conductor. Then they get another one. One end is not sharp. Okay, to avoid corona effect, they get another one which also twist around this one. Okay. Like this. It becomes one. After, it becomes one conductor. One conductor. And they use it on the 3-phase conductor, carrying one voltage. Voltage 1, voltage 2, voltage 3 phase lines. And this is the high conductor. This is what the engineers came up to reduce the effect of corona effect. Now this effect of corona effect, to avoid sharp ends of the conductor, what they did on this transmission, one cable went is big with big diameter, so that these electric fields will not penetrate. The corona effect will not ionize with the air. Once it is point, it passes through. And another point they did, they decided to bring some rings which holds the ends of the cable. At the end of the cable, they close it firmly with a ring, so that corona effect will not affect the conductors. Okay, now we want to see how these effects matter in transmission, in high voltage transmission lines. Why this corona effect is so important in transmission, in high voltage transmission of electricity. One of the point is it makes the company lose electrical power. You know this bluish color you see, or violet, it is power loss. Power loss. This corona effect brings power loss. A lot of power is lost in this ionization of air with electric fields. A lot of power is being lost. Someone you see, if you see that bluish color, that purplish color, just know power has been lost. And that is the effect, one of the effects of corona effects in our transmission, in our system. It makes a lot of power losses, and engineers are getting solutions for it. You know what the engineers did on this corona effect to avoid this corona effect? By using a very big diameters in the cables. These transmission cables, they use big diameters. Big diameters. This transmission, when a conductor is big, it reduces corona effect, because electrons will have space in moving in the conductor. Only when they are very many and with a small conductor, they will move out. And once they move out, they ionizes with the air molecules. And once they ionizes with the air molecules, corona effect will happen. You will see that bluish color, that purplish color. That is corona effect. And you will hear some sound. Those sounds, they indicate corona effect is happening in that area, in that conductor. Okay? Another thing they did is conductor spacing. Conductor spacing. Spacing these conductors. Spacing these conductors on the transmission. One conductor is spaced with a because air also acts as an insulator. Not only we need an insulation on the cables, but also if you space, this air acts as an insulator. If you bring close these conductors on the transmission lines, on the tower, its closeness, it will bring an effect of the effect of this magnetism which is passing through this cable will interfere with the magnetism of and it brings cable power losses. Okay, now what the engineer did, they put spacing of these cables, one cable the other side, another cable this side, another cable the other side. Good spacing. It reduces the corona effects. Okay, now another thing which I can tell you how this corona effect is driven. Number one thing is high voltage. High voltage. It starts with the high voltage. When there is high voltage will produce, when there is high voltage will produce a strong electric field. High voltage produce a strong electric field. A strong electric field on the cable will produce an ionization to ionize the air molecules. And once the air is ionized with the high electric fields, strong electric fields, there will be an effect of corona effect. That is when you will see that bluish color on the conductor and you hear that sound, the hissing sound like small birds. But it is not like a transformer humming, buzzing, but it's not a transformer, and even the cable is free. It is not vibrating, only because of that effect of corona effect. And that is how it is moved from high voltage to a strong electric field. High voltage produces strong electric field. Strong electric field ionizes the air molecules. Once the air molecules are ionized, they will have a corona effect on an electric conductor in these transmission lines. Normally it is done, you hear this corona effect on high voltage transmission system, in transmission systems. Okay, now if you have learned this, I will be so glad that you do also a practical thing. Look for these transmission lines, try to listen, give it time in silent, then you will feel the corona effect on these transmission lines. This is a tower, and these are lines, the three-phase lines. If you hear that sound, just know that that is a corona effect taking place. And I didn't want to leave this behind. I want you to have everything in transmission and to be good in whatever field you are. If you're going to be in transmission companies, if you're going to be in generating companies, or if you're going for distribution companies, you need to have all the knowledge, be multiple, so that you are stable in whichever side they put you. Okay? With this, I call it a day that you have gained something. Write something down and you will have a meaningful future. Thank you for watching. Subscribe if you're new on this channel for more engineering lessons, more engineering and practical lessons in electrical engineering, electronics, and solar. Though we haven't started electronics, but solar systems, solar videos are already there. If you want to open up a solar company, there is a video which directs you. Without knowing some solar knowledge, you can't open up a solar company. Solar company is very easy to start off if you have the knowledge. The knowledge of electrical is the mother of everything. You can't wire something. Wiring, still you're dealing with electricity. In solar, you're dealing with electricity. In electronics, we are dealing with power systems, electricity. So electrical is the mother of everything, all technologies in the world. Without electricity, there is no technology which can work. Without electricity, your TV cannot work. A repair technician, we shall see how electricity helps us when we start the repair part in electronics. Your phone cannot work without a battery, that is electricity, DC. Solar system cannot work without a panel to generate that electricity, DC power. Electricity is the mother. Now, transmission, we are on a transmission systems. We finished the generation, we are on transmission. We are going to on a distribution very soon. Don't hesitate to miss. If you're new, subscribe and like, share with your fellow engineers, fellow students, so that we move together, we build the world together. Thank you and see you in the next video. We are on transmission. Don't forget, we are on transmission. Soon we are ending transmission and we go on distribution. Okay? Distribution is where we are going to start wiring. Cables, which cable you use, which conductors, which circuit board, circuit breakers, how you install a main switch, how you do the earthing. That is in distribution part. Thank you and see you there. In the next video about transmission. We are still discussing about transmission. If I get something new, you are going to have it. Because I don't want to give you everything in one video. It will make you tired. You need to have bit by bit, as lessons move on. Thank you and see you there.